behavioral data used for fraud detection. It's great for making predictions about people, whether this person is trying to commit a fraud or not. Financial services companies look at people applying for loans, the way they're filling in the different fields. We often want to make predictions. You might want to optimize the customer journey to buy something. Behavioral data is great because it helps us really understand, in the case of people, the decisions they make and the context that they make those decisions.
Yali, thanks for joining us. What is behavioral data?
Thanks for having me, Florin. Behavioral data is data that describes how things behave. You can think about people, and behavioral data can describe what they're doing second by second and minute by minute. So if you think about, for example, somebody on an online shop, behavioral data will describe how they enter the shop, what products they view, how they browse the products, which ones they add to basket, which ones they remove from the basket, what content they watch and consume around that when they transact, and so on. Behavioral data can describe people that are not necessarily customers. They might describe employees. So organizations might have supply chains. A media company might have groups of people working on new films. And there are multiple stages in that film production process. And the behavioral data might describe what those people are doing as they create that film. Behavioral data can describe machines. So machines behave in particular ways. So if you've got a manufacturing plant and you're building cars, for example, you can create behavioral data that describes what the robots in your manufacturing plant are doing. Behavioral data is very interesting data because we often want to make predictions, and predictions we want to make are about people, often customers or employees or machines. We want to optimize processes. We might want to optimize the customer journey to buy something, or the car manufacture process, or the film production process. And behavioral data is great because it helps us really understand, in the case of people, the decisions they make and the context that they make those decisions. So you can use that data to predict what decisions they're likely to make and what factors will influence them. And similarly for machines, you can see exactly how the machine performs, and then you can start making predictions about when you need to service that machine, how to better network that machine into other machines to optimize the production process.
And back to your retail example, I'll frame a few questions that might make me sound old, is because these concepts, I haven't visited them in the past few years, but I remember the state of the market maybe 5, 7, 8 years ago when I had to interact with them. I used to work in mobile publishing. So think like cross-device monitoring and attribution and so on were some of the big challenges. I was wondering, in the meantime, has it become easier to be able to unify into one profile a user/consumer and track them omni-channel? Has it become more accurate?
It's not easier or more difficult. It's different. The challenges are different today than they were 5, 10 years ago. The challenge is, if you go back 10 years, actually just creating and processing the volume of data to build a customer 360 was very challenging. Like, just looking at, if you think about omni-channel retailer, just the data from one of those channels, it might be telephone, it might be web, it might be for a single customer, you're talking hundreds, thousands, tens of thousands of records. And across a large customer base, the volume of data gets enormous. And then processing that data at scale became challenging. So that was the case 10 years ago. In the intervening period, the technology for processing and managing large volumes of data has got much, much better, much, much easier, and much, much more cost effective. And so that thing that was really a big challenge 10 years ago, 10 years ago, you were doing the stuff in Hadoop. That was no fun for anyone old enough to remember. The cloud data warehouse has really changed that. So actually, then the ecosystem around those cloud data warehouses and data lake houses really helped with that. So creating all that omni-channel data, which is largely behavioral data, became much, much easier. And I like to think at Snowplan we did a little part of making that easier and making the data available in the data warehouse. But then there's a separate challenge, which is how do you reliably identify an individual, first of all, within a particular channel? Because if a user comes on a website, clears their cookies and comes back, it might be difficult to spot this is the same user and a totally different user, but then spot that same user across multiple different devices. That today is in some ways significantly harder than it was 10 years ago. 10 years ago, you could set some pretty outrageous cookies that would identify people all across the internet pretty easily. It is kind of shocking. And legally, that was completely fine. And there were all kinds of third parties in the ad tech space that were building enormous databases of user behavior across different places and using those to build unified profiles. So today, my view is you can really only reliably identify users across devices, across platforms, if you do it in partnership with the user. As if a user puts their hands up and says, hey, I'm Yali, and you can track me, and then you can say, hey, look, I can see Yali on the mobile, I can see Yali on this web device, I can see Yali in our call center, and you can build a complete view. And that is relatively straightforward. But the idea of doing that in the absence of a user putting up their hands, that's very difficult today. It's I would say it's largely impossible. There's a whole ecosystem of organizations that try and enable you to do it, but I don't think any of them really do it reliably.
So how do you work with this?
Organizations that want to build strong customer relationships and serve their customers really effectively and consistently across different channels have to be open and honest with their customers about what they do, and if they are, customers are often very happy to identify themselves, and then they have the legal basis to make those connections, and they have the basis of the data. They can create data from these different channels. They can pull all that data into the data warehouse. They can build those rich, unified behavioral profiles. And then the key thing is the organization needs to use that intelligence to drive better customer service and better customer value. And if the customer sees, hey, look, I'm giving up, I'm being transparent about who I am and where I am and what I'm doing, and this organization is using that information to provide a better service to me, that customer will be more loyal, will be happy to keep sharing that information. It becomes part of a relationship building exercise with the brand, and value should be created both for the customer and the brand, and then it works great. And data is a part of that relationship. It's one of the things that sort of traded in now value exchange and used to create value in both directions.
I love the concept. I don't know, so I'm a bit removed from how B2C works in this day and age. Thinking of my experience in B2C, are the users educated enough to understand what you're doing with the data? If you're a brand, you're trying to communicate that, because that's what you're suggesting, right? You should have the user agree to the fact that it's win-win that you process their data for specific activities. Are the users informed enough, and secondly, are brands trustworthy enough in the perception of the user for this to work at scale?
Look, not all brands are trusted, and not all consumers are trusting. There's a spectrum. There's very good evidence. There's a McKinsey study that was published, I think about a year ago, on personalization that showed that customers really reward organizations that personalize the experience. They're more likely to repeat purchase and so on, where they see personalization being applied correctly. And there's some interesting studies on the brands that consumers trust. So I always come back to Amazon. Everybody logs into Amazon. Amazon knows everything about you, and we keep shopping at Amazon because it's one of the fastest places to get what you want. So they've got that virtuous circle I think people really trust, which is great for Amazon, because the data that they're creating, if you think across not just retail, where they're across every category, but Alexa and the Home, their different Fire tablets and so on is astonishing. So I don't know that people understand, quite how detailed the data is, or the types of machine learning that are performed on it. Like that nuance I think is lost. But the idea that that these organizations, when you're engaging with them, can see what you're doing and are using that to personalize the experience, I think that's reasonably well understood. And at least some brands seem to be trusted to do that, and it feels like quite a few brands. Maybe the consumer base is very polarized, because you've got this hardcore segment that are ad blocking to the hills and giving nothing away, and I don't know. I think shopping is a lot more effort for them, but you can, if you want, keep your data much closer to your chest.
And as we see with Amazon over time, becomes this trust and the effects of it becomes for the company one of the most important modes.
Yes. Yeah. So I think it's that how you build that trust is really differentiating today, and every consumer-facing brand should be looking to build that trust. And there are huge brands like Amazon that have been successful at it. They're much smaller brands that target niches that have also achieved it. So it's something that I think all brands should be thinking about.
We speak about retail a lot, but I'm sure this kind of mindset is becoming mainstream across industries, probably in everything B2C.
Yes. So you think about financial services and everything that your bank knows about you and the way you engage, and you think about fintechs like Revolut, and they're now offering more and more services and offering you vouchers and points to spend money on different consumer products. So they're really starting to build a rich picture, not just of how wealthy you are and how you manage your money, your temptation to spend versus save. And then they use that to send you targeted offers and so on. So it's there in financial services, it's there in media. Think about, the Netflix experience is very, very highly personalized, and the same is true for a huge amount of media. So I think every sort of consumer facing brand is doing some version of this.
Can you give a few examples from what you're seeing Snowplow customers do? Because, for example, when you mentioned Revolut, thinking about the kind of data Revolut has access to about yourself, as long as they use it ethically and they don't sell it or do anything weird with it, it's probably a better proxy to your personality than even your internet browsing activity. One's spending habits probably correlate exactly with the type of personality they are and what they do in real life without even knowing anything else. Can you give a few examples in different industries? I'm curious where the market is at now.
One of the interesting things about behavioral data is it can be used in so many different ways. So personalizing the user experience is definitely a big part of it. So a nice example, I think this is a few years old, but a Dutch online grocery company called Picnic, and they're mobile only experience. So you buy all your food for delivery via an app, and they can only show a certain number of products on a mobile phone screen. So figuring out which products to show so you're not having to relentlessly scroll across is really important. The behavioral data is one of the inputs. Two different Picnic customers will see totally different products when they load the app based on that. And that's a really standard example, because you've got an enormous number of SKUs, particular user, you want to get to showing that user what they want as quickly as possible. Another example of a similar thing in automotive, that's a little bit more subtle. Auto Trader in the UK, which is a very large, is the UK's largest car marketplace. When you perform a search, the results you see will be a function of the parameters you put into the search. But through your browsing behavior, Auto Trader can also understand things like whether you're more interested in electric cars versus fuel cars, or estate cars versus hatchbacks. So they can use that information to further personalize the search and make it that much more effective. And they've seen quite significant improvements in conversion, because even though a user could put those preferences in the search, you're actually just saving them work. People want a quick and easy experience. So personalization is one example. At completely different ends of the scale, we see behavioral data used for fraud detection. And if you think about it, this comes back to that point I made earlier. Behavioral data is great for making predictions about people, whether people will buy, and whether this person is trying to commit a fraud or not, or whether this person is actually a malicious bot or actually a legitimate human being. So we've seen financial services companies that look at the behavior of people applying for loans, and like the way they're filling in the different fields on a form. And there's certain behaviors, like if you see people copy pasting multiple social security numbers, that's very suspicious. People only have a single social security number. So somebody's pasting it almost suggests that they've got a list of identities that they've stolen and they're working through. So there's a lot of signal in that can help.
Would this kind of example work with something that resembles an unsupervised model, or is it, because one of the challenges, we have clients that use our data mixed with a lot of internal first-party data for fraud detection in different use cases, especially financial services. And I was wondering, one of the challenges is to find a golden data set, and definitely one of the challenges for us in improving any sort of correlation between attributes other than like a sales pitch, like an actual correlation, is finding a golden data set. I was wondering, does this kind of prediction work with a golden data set, or if you work enough on how you structure and process the data, do you see like a cluster of just weird behaviors?
I think we see both. I think we see clusters of odd behaviors, and behavioral data. There's such odd stuff. Like web data particularly, there's all kinds of weird stuff. So I remember in the very early days of Snowplow. I mean, I'm a data geek. It's going to make me sound very geeky, but I just got this massive kick when we did the first version of the software. You put it on a website, and I'd literally read the effectively the web logs and look at the different things that were on our website. I assume that they were all people to start off with, quite naively, and then you see someone jumping between different geographies like every few seconds, or performing 5 events at the same time, and you're like, oh, actually, hang on, this is a bot that's just systematically going through and crawling it, all this information. Or you'd see machines with weird device timestamps, and you could compare them against your server timestamps, like what's going on here. And I later learned that was a common route around, I can't remember what it was. It was something to get around some restriction where you're allowed to do something for some time period, and then you mess around with your local clock to give you to extend the free period or whatever. So you see all these sorts of weird behaviors, and unsupervised models can be quite good for pulling them out of large data sets. I think with fraud, though, they often you do end up with these golden data sets that you can come back to, because you can flag the transaction, let it go through, and then investigate it after. So I think we've seen both approaches there, but there's definitely some really weird stuff in the data. Basically everything you can imagine, somebody or some bot is doing that on the web.
I used to read statistics like more than 50% of the traffic is bots, and I wouldn't believe them, but I think it's true.
I think on some websites you'd really see some of the customers we worked with that had maybe very large product catalogs and were in very price competitive markets, so their competitors would be crawling their sites. So that was quite interesting. I learned about a whole new type of fraud just recently in the travel industry, where travel companies will they're bots that go on travel companies' websites, and they go through the booking process to book trains, like seats on trains or planes or hotel rooms, or you're booking things where there's a limited capacity. Put it in the basket, then hold it there, so they've got to then reserve that capacity. They can't sell it. It's very, very evil. But we talked to one of our open source users that we're using our technology to spot people doing that and block it, because there are certain behavioral signals that are quite predictive. Like if you can see a single agent that's blocking 30 different hotel rooms at the same time in 30 different locations, that's super suspicious. And if they're always coming back and doing that just before the date in question, that's super suspicious.
Yeah, and this, for you as a platform, you have this crazy advantage that you can see across different. I'm guessing what you're describing is actually a competitor's attack, right?
I assume so. I mean, I don't know too much about it, but it's either competitor or it's some sort of evil third party. I don't know. We saw in like the first types of fraud that I personally saw when I was looking at the data were ad fraud. You'd see, these agents coming in and just clicking on an ad and then disappearing. Like, what's going on here? And actually, they all have their same IP address. So there's lots of bad behavior on the web, and the behavioral data is great for spotting that and identifying that and dealing with it. There are other sort of customer-facing use cases that are valuable as well. So, in terms of customer acquisition, we see brands that build models that predict customer value based on engagements. You might be a games company and monetized by in-game purchases, and there'll be certain signals that you can see when a player starts to play the game in their first 48 hours of play that might be predictive of their overall lifetime value. And if you can use that to then target similar users or bid up on the campaigns that win those types of users, that can be a very effective customer acquisition strategy. And we've seen sort of comparable things being employed in retail, D2C, and others. So anytime you're sort of competing for attention for users, and you're having to spend that, the better you understand those users and can really value them based on this data, that often gives you a competitive advantage over the people you're bidding against. And so there are a whole set of use cases. Their churn reduction is another. If you run a subscription service and looking at how people are engaging with your service, you can start to spot engagement is waning, or if there's signals that somebody's likely to churn, and then try to intervene with an offer or something to hook the customer back in and reignite that customer engagement. So there's a whole host of use cases beyond personalization. The fraud detection are probably some of the most wacky, but they're definitely lots in between.
And also probably one of the highest value, though.
Yes.
I'm curious, Yali, because a lot of I'll probably sound naive, because
No, I doubt that.
I'm trying to imagine how it works with what I know about machine learning and data science today, but using reference experiences from maybe 5 years ago. For example, we had to build an internal analytics system. We had published about 10,000 apps, and there was no system that did real-time user tracking across apps. And with the predictions we were trying to do were basically everything you listed. We were trying to see every click as real estate, notifications, ads, in-app purchases, whatever. And we would basically try to predict the likelihood of a group of users at the group level back then, a group of users to do a specific action. And based on that, we attribute a value, and we would attribute a value, and we would basically see what the action that makes sense the most for that particular group of user is. Should we try to lead them to long-term retention, or to purchases, or to show ads? Or I think compared to what you can do today, it was extremely naive. So it's built on old infrastructure. We've had to take samples from Redshift to do that in real time. Very, very different from today's world. Comparing to what we did then, it was basically one model with different flavors on it. So churn would just be a different way of reading a score than retention, right? In today's world, is this kind of system built by clustering users and what we know about users, or clustering actions and what we know about actions? I imagine it's a mix of both, but I'm wondering, when you build a model, do you tend to look more at what you know about the user?
It is mostly about the user.
Okay.
So it's quite interesting. There's the technology, the tooling in machine learning has come on leaps and bounds. Actually, if we look across our customer base, what we find is most of them implementing, not all of them, there are definitely some that are doing deep learning and a whole bunch of stuff, right? The LLM stuff now that I really, only understands to a very superficial level. The bread and butter, what we see across most of the customer base, are simple models, only a handful of features, but the features very, very carefully selected and engineered.
Yeah. End of the work is in testing, probably.
Yeah, and that works. That drives a lot of value. I often ask both sides. I ask the guys doing the deep learning. I haven't talked to too many people doing the LLM, because that's still everybody's kind of experimenting with it, but with the deep learning, like, why are you doing a deep learning? Why aren't you keeping it simple? And some of them are like, actually not that difficult doing it this way. We don't have to feature engineer. We just push the data in. We get the prediction. It works. We're happy. With this for us is simpler. But then you talk to the majority of folks that have got the simple models, simple features, simple predictions. They're like, look, this works. We like the transparency. We like the understandability. Why overcomplicate? Both groups feel like what they're doing is right and straightforward. And in the same way as in analytics, the best insights are driven by the best questions. Use the most sophisticated analytical technique in the world, but if you're asking a dumb question, you're not going to learn anything interesting. I think the most effective uses of machine learning are about just carefully selecting what part of the user experience, if you're doing personalization, you're going to personalize. Because you could personalize anything, but personalizing that, like if you're the supermarket, when you're landing on that homepage and making that the best possible experience is super important. So that makes a huge amount of sense. And then picking the right strategy, whether that's a simple or a complicated strategy to do that, but that works for the customers there, that's the more important thing than whether you're doing something more sophisticated or something simpler. And it definitely seems to be something in the feature selection piece. We keep seeing across across use cases and across customers. One of the most predictive things, if you want to understand users, is the time they spend doing stuff, and measuring that time accurately, which is something we spend a lot of our time with our customers on, is really, really valuable, because we live in this world where there's so many competing things for our attention. And actually, we only have a finite amount of attention. So where we spend that more than where we spend our money, I think is becoming predictive of us. And so on web, we do things like fire heartbeats and so on. So we really understand somebody's active on this page and they're mousing over this particular piece of content. That's really important. They spend 3 minutes on some piece of content. 3 minutes is ages in web. So that there's some real intention there, and that can be very predictive. But to come back to your question, it's all being aggregated up to the user level for those simple models.
Which, if I understand correctly, Yali, what you're telling us is that it's 90% of the work is how you collect the data and how you cleanse it, and how the type of assumptions that go into different processes like merging of different data points.
So I think that's very important. I would say that because at Snowplow, that's what we do. We help companies create these really great data sets that are optimized for AI and analytics. We really try to make it easy so that you don't have to spend too much time cleansing data. The idea should be, if you're creating the data right in the first place, what we're hoping our customers are doing is just aggregating that data to the user level in the right way to engineer their features. If they've got this very rich event stream of data, so think, one line of data per event, you're then, aggregating to the user level, and you're figuring out for each feature, I want to know how much time do they spend against these six types of content, and aggregating to that. And you've got like a measure in seconds and 6 features with six different types of engagements. But yeah, I think the point is thinking about what features are likely to be predictive in engineering is really valuable. Hopefully the engineering companies like us are making a lot simpler, so companies can really spend their time thinking about, data scientists can spend their time about what they want to know about their user, what they think is going to be predictive, testing that, seeing that it works, and putting that into production really quickly, and focusing on the business value instead of the data prep. But the data prep,
even for a retailer, probably to change something in data collection, they probably need to update the apps and change a bit of how the app is built, maybe even to capture some data.
Often. It is a very active area of development for us. So we want to evolving our platform so that before any data flows, there's a data product manager at the organization that's saying, hey, we want to create this data that describes customers doing this, and this is how the data is going to look. And then the tech should make it, our vision is that the tech should make it so that once everybody agrees that that's what the data that they want, as much of that should be automated as possible, and it should land in the data warehouse. It should land in Kafka. They can go off and consume that data and start doing something important with that data.
So what has changed in the past 5 years? How is working with a platform like Snowplow, how is it different than what we used to use back in the day, like a mixed panel or a Localytics? Or
a lot's changed. There's sort of 2 questions wrapped in there. Like what's changed more broadly in data, than how has Snowplow contributed to that change, and what changes has Snowplow made? So I think the big changes that have happened in the last 5-10 years are the tooling for working with data has got much better. A lot of the data engineering challenges are much smaller, and so and the tooling for doing machine learning and AI has got much better. So you're seeing organizations that are doing much more with data. They're creating more data. They're making more predictions with the data, building more reports with the data. If you think back to sort of the analytics landscape, the digital analytics landscape as it was like 10 years ago with mixed panel and Localytics and Google Analytics and all the rest, what you had were sets of point solutions that were used by particular personas to solve particular problems. This is going back 10 years. All these platforms have evolved, and platforms like Mixpanel we're big fans on. So I'm not throwing shade. I'm just want to. But if you go back 10 years, Mixpanel was a product that was used by product managers to do cohort analysis and funnel analysis, and it made it super easy for those product managers to select their events and graph them, and that was cool. And if you looked on a website or a mobile app, you'd see lots of different SDKs that be implementing. Marketing would implement a load of SDKs. Products would implement SDKs to solve different problems. Today, what we see with Snowplow specifically is companies looking to collect the data once, but really do that properly. So instead of having 8 SDKs, have 1 or maybe 2 tops. And that's because the way that they're using the data is much, much more sophisticated. And so the requirements on the data in terms of accuracy and completeness are much higher. If you're using this data to do machine learning, the data needs to be better than if you're using it just to measure your traffic patterns or to do a cohort analysis. If you're doing a cohort analysis, actually 40% of your data can be missing and your cohort analysis can be perfect. But if you're doing a prediction, and 40% of your data is missing, that's a disaster. Companies, I think, are realizing, data teams are realizing they have to spend much more energy deliberately tracking things. And 10 years ago, we literally had people saying, I used to get in arguments with people saying, we should just be implementing tracking and not caring what it looks like, no governance, engineers need to move fast, data people, you can figure this shit out later. And for, all of us in data were like crying because all this, nobody knew what any of this data meant. That's really, dead 10 years later. So everybody's, not everybody, but more and more organizations are very deliberately creating rich data. And then you're pushing it to the different places you want. So if you're landing that data in the data warehouse, which is very much what Snowplow advocates, then you can put Mixpanel directly on the data in the data warehouse, or Amplitude on the data warehouse. And those tools can consume off that. They don't need their own SDKs in. And that's how product analysts might consume them. And then, new product analytics tools like Qubit and NetSpring that are built to be data warehouse native. But you've got then the same set of data that's used by the data scientists to build predictions, and the same set of data that's used by the marketers to do attribution and understand what different channels are creating. So with Snowplow, we've hopefully moved the market to the much more deliberate data creation. We've helped sort of cement the lakehouse and the warehouse as the primary destination for this data, and helped organizations and think about all the different ways that they can, and tools that they can plug into. And there we've been lucky that this ecosystem has grown up around the lakehouse and warehouse to help organizations do that.
I'm very happy with what I'm hearing, because I think it's a token of how it's a token of education. I think it's a token of how well organizations understand data today, and probably also a consequence of the fact that there's probably a dedicated data team that just does data. It's not affiliated to the marketing team, to the sales, to the IT team, whatever. Because I remember one of the big challenges was the tool would define concepts like the session. And I used to hate that. What we actually needed was exactly the approach that you're describing. You grab probably all the data you can think of. There's a challenge because you need to do it very efficiently. Because if you send 500 kilos per minute of data from the user's mobile, they're just going to uninstall your app. Just grab it, put it in one place, and then slice it differently for different use cases, right? It's even simple concepts. Like what an active user is. You might want to have the freedom to define them differently for different purposes.
100%. Those definitions really matter, and having somebody force you to apply a particular definition, especially for a session, is madness. There are very few businesses where the session is the right unit of analysis. My favorite example there is we're a family, and we do Tesco is our supermarket. We do big Tesco orders. I've got 4 kids. The Tesco orders is really big, and we do a couple of them a week. And the basket is open from the moment the shopping arrives. We realize there's 3 things we forgot to go on the app and add them to the next basket, and then we're adding things for the next 3 days until the next order arrives. So the unit of analysis is the time period between the 2 deliveries. It's not the session where I happen to add two items. You want to understand that part of the behavior, and then the behavior over multiple sessions. And it's just a very stark example. But active users is the same. But what level of activity is right is totally different. If you're a newspaper and you might just want people to come in once a day to scan the headlines, versus an online game or dating site.
We have a product that's a search API. And we're trying in the way we define success of using that API. After the third attempt to search for the same thing in different ways, we count that as a negative API call. And I think it's very similar to what you're describing. As if you're in your third day of updating your basket, there's probably something that the brand can do to limit.
Speed that up. Yeah, that's not a good experience. Yeah, that's exactly right. That reminds me actually of, I think Google in the early days, their KPI was how quickly they could kick you off the Google search, because you should just find what you want to be gone. And it's not like that anymore. They want to keep showing you ads. But yeah, once upon a time, it was more similar to your search API.
What you're describing is the right way to do things. And if that's the state of the market, then why to us users, it seems like brands aren't really learning and applying personalization and evolving? Is it that hard of a job and it's easy to move the needle from the brand's perspective, and the sort of details that really make an impression on the user, it's in the diminishing returns area? Or is there a lot of work to be done and it's not actually mainstream, this way of thinking?
I think both things are true. So they're companies that are doing this, and they're doing this at scale, and they're very successful. And when you're engaging with one of them, because you can see that the experience is personalized. But there are lots of brands that are struggling with it, because you need people like the data scientists and the data engineers. You need the right executive alignment, like to make the projects happen in the space that they can make a difference. And you need the right culture. The companies that tend to be good at this are the digital natives, and then the fast followers from the more traditional companies. That some more traditional companies are much better at embracing new technologies and new approaches and rolling them out. So they look and feel a lot more like a startup than a big company. But a lot of organizations struggle, and there is a shortage of talent. Although the talent thing is changing. There are a lot of data scientists out there. There are a lot of people studying data scientists and then struggling to find jobs. The data engineering thing is real. So yeah, it's not. I don't want to be glib. There's lots of organizations that are doing this, but there are lots that aren't yet as well.
And the ones that are doing it, are they trying hard enough? Would you say they fully realize the potential of what can be done?
No one is fully realizing that there's so much that can be done. It's everybody's in their different part of the journey, but you can sort of see everybody on the journey. So a few years ago, when people started getting really excited about feature stores, for me, marked the moment where you had a certain number of companies that had a certain number of models out there in production, and they realized that they could reuse the features across multiple models and use cases. And so that wasn't a problem when that market was created by a certain number of companies reaching that point in time. And it's interesting, you're looking at all the tooling around LLM, and there's something similar that's happening there. Although there's also everybody getting carried away with the hype. So the possibility is always expanding, because the tech is always improving, and everybody's in their own place figuring out how quickly they're gonna adopt this stuff and figure it out. But we're all on the journey.
You've been around for quite some time in the space. You've founded Snowplow 11 years ago, I think.
11 years, yeah.
Sounds crazy to me.
It sounds crazy to me too.
I imagine that 10 years ago, the space was barely moving, barely changing the way people thought about data and how to use it and make predictive models and how to optimize the different output and just think about data science in general. I imagine it was barely moving, and then there was a wave when tools like Snowflake and Databricks became mainstream, and big data was the word of the day at every conference. I imagine that was moment number one when things started moving quickly. Is this moment number two, or is anything wrong with my assumptions?
I think things were really changing very rapidly all the way through. It's just the nature of the change was different. So when we started Snowplow in 2012, people were really excited about big data, and people call themselves big data engineers. And We were all learning MapReduce, and we were all living in EMR, and it was all Pig and Hive, and that was really exciting. And it was really exciting because before then, that you hadn't been able to horizontally scale your data infrastructure, and you had to have some really expensive server running, trying to figure out how to scale MySQL. And it was just it was just a nightmare, and working with unstructured data was kind of impossible. And so there was a huge amount of excitement around Hadoop. People were using it for machine learning. Back then, there was a lot of excitement around projects like, I think, Mahout or Mahout. I can't remember how
I don't know.
it was pronounced. It was just much, much harder. A lot of the challenge was just in standing the damn thing up and getting your query to execute without like stopping halfway. And the whole thing was just quite miserable. But it felt like real progress, and it felt like things were changing very fast. And then the stream processing stuff came along. We were all excited about real time and microservices, and the progress and the technological innovation, I think, has been going along the whole time. There was a moment around the warehouses and the lake houses, the Redshift, Snowflake, Databricks, which just meant they really got more companies thinking much more expansively about their data and getting much more ambitious. The machine learning tools have got much better. The auto ML tools, things like SageMaker and so on, have had a huge impact in the way organizations do machine learning. So the tech keeps evolving. There's always been lots of progress. I think that the interesting things today are not around the technology. They're around compliance. Compliance is a real challenge today, and it's managing the tension between compliance and data democratization. There's a real, if you're only allowed to do certain things with data, you can't just make it freely available within your organization. So that's a tough challenge to solve. And then often for organizations to be successful with data, to get to value with data, you need cross-disciplinary groups of people organizing around the data to make a personalization strategy successful. And that can be hard. So I think the organizational challenges are some of the most difficult. So I think we've moved from technical challenges being the thing that we love to talk about to some of these other challenges. And if you think about all the excitement around concepts like data contracts and data mesh, they come a lot from some of these organizational challenges that are now the things that are really holding organizations back.
Thank you so much. This was a pleasure and really fascinating for me.
Thank you for having me, Florin. It's been an absolute pleasure talking to you.
If you're okay, I'll have you again in like 6 to 9 months or so.
Be awesome. I'd love that.
Thank you so much, Yali.
Cheers.